Welcome learners to today's lesson. Today we are looking some of the common questions which are set from water and hydrogen, and that is the reaction of metals with steam. Metals which does not react with cold water, they normally react with steam. An example of those metals you can have magnesium is one metal which does not react with cold water. Then we have zinc metal, and then we have the iron metal. So those are the metals which react with steam. And in this case now, when these metals react with steam, there is a formation of metal oxide. If it is magnesium, there is a formation of magnesium oxide. If it is iron metal, there is a formation of the iron oxide. If it is the reaction of between zinc and steam, there is a formation of zinc oxide. So in this case here now, you need to understand the sources of steam. Where do we get this steam from? We can either have this steam by heating the sand. So you heat the wet sand, it can just generate steam. Heating water can just generate steam. You can also heating the cotton wool. Cotton wool can also generate steam, or heating the hydrated salt, a salt that contains water of crystallization. When heated, it can just generate steam. So from here now, from as you can see on this diagram, that in this diagram we have the magnesium ribbon here, then we have the sand, then we have hydrogen gas being collected. So in some cases now, the gas will not be labeled to you as hydrogen gas. It can be labeled, it can be indicated at gas K, so it is you to identify that gas K, or how can you confirm the test for that gas K, or to describe an experiment to confirm that the gas produced is hydrogen. So in this experiment, where a magnesium ribbon react with the steam to generate hydrogen gas, magnesium it normally it's magnesium, it burns with a bright white flame, and then it produces a white solid. The white solid is just magnesium oxide. So what are some of the expected questions that you want to you can test it from this particular diagram? As you can see here that the magnesium ribbon is coiled. So this magnesium ribbon here is just coiled. Why is it coiled? Give a reason why the magnesium ribbon is coiled. Magnesium ribbon is coiled to increase the surface area for it to be in contact with the steam. So that is the reason why the magnesium ribbon is coiled, to increase the surface area to be in contact with steam. Another question that you can be getting from this diagram, it is state and explain the observation made in the test tube and in the gas chamber. So in the test tube, as you can see here, there is a reaction between steam and magnesium ribbon. So during that reaction, there is a formation of a white solid. The white solid is just magnesium oxide. So what you can see in this test tube here, in the test tube, you can see a white solid of magnesium oxide. In the test tube, in the gas chamber, in that gas chamber, you can see that there is an hydrogen gas there. So in that test tube, what you can see, it is a colorless gas. And that colorless gas is just hydrogen gas. So that colorless gas is just an hydrogen gas. That is what you can see there. So suppose now in place of that magnesium ribbon, we are using the iron metal. What is the likely observation are you supposed to make from there? When an iron metal is used, there is a formation of a black solid of iron 2 oxide. That is what you can see. So if you are using if you are using an example of zinc and magnesium, there is a formation of a white solid. Zinc and magnesium, there is a formation of a white solid. But if either zinc or magnesium has been replaced with the iron metal, the observation now here, there is a formation of a black solid, and the black solid is the iron 2 oxide. That is what you can see. Another question now, state 2 reasons why the sand or the glass wool or the cotton wool is heated first before hitting the metal. So why do we heat the sand first? Why do we heat the sand first? Or why do we heat the cotton wool first? Or why do we heat the sand, the wet sand, the cotton wool or the glass wool first, the wet glass wool before hitting the sand? So the reason why we are heating that one, it is to drive the first reason why we heat the sand first, the wet cotton wool or the wet glass wool. It is to drive out the air that was initially on the test tube, which might have reacted with the magnesium vapor. Number 2, it is to generate steam. The steam generated to react to the magnesium ribbon. So first one, it is to drive out the air that was initially on the test tube, which could react to the magnesium ribbon. Then the other reason is to generate steam that will react with magnesium ribbon. So the precaution here, the air must be driven out fast, and therefore then the steam will be generated, which can react with the magnesium ribbon. The other question is write a equation for the reaction that takes place. So if you write an equation that takes place, I will not be able to write the equation on this screen here. You can just take when you're writing the correct chemical symbols, it must have a correct chemical equation. It must have the correct chemical symbols, and the equation must be balanced. But for in case of a form 1, it is just magnesium ribbon plus a steam, and then you get the product of magnesium oxide, and then there is hydrogen gas. For the candidate class, you just write a correct chemical equation, which must be well balanced, and it should contain the correct chemical symbol, correct. Describe a test for the gas produced. This gas produced here, it is just hydrogen gas. How do you describe that this gas produced is hydrogen? How do you confirm that the gas produced is hydrogen? In chemistry, any question which requires you to describe an experiment, if you are required to describe an experiment, make sure that you understand or to identify the apparatus which are being used. After identifying the apparatus used now, use those apparatus, tell an examiner, give the procedure followed by the apparatus that you have identified. And then from there, you are supposed to give an observation from that experiment. So if it is describing this gas out that the gas to produce is hydrogen, so we need something that where the gas be collected. So in this case here, you need a gas check. So if you need a gas check, you collect that hydrogen there. Another thing you need a panning splint. You will need a panning splint. Then after you have a panning splint, of course, a gas jar, a panning splint. Now you will be able to describe and tell an examiner how do you confirm that the gas produced is hydrogen. So for in case here that you lower a panning splint into a gas jar containing hydrogen gas, or you can just say lower a panning splint into a gas jar suspected to contain hydrogen. Why do we use the word suspect? Because we are not very sure that the gas produced is hydrogen. So you lower a panning splint into a gas jar suspected to contain hydrogen. Then what happens there? Hydrogen gas, it extinguishes a panning splint with a pop sound. So it is not that we are saying that it burns with a pop sound. No, it extinguishes a burning splint with a pop sound. That is how you can describe that the gas produced is hydrogen. Another common example that you can get from here is that explain why sodium or calcium or potassium metal are not suitable for this experiment. So the reason why this one is not suitable for this experiment here is this because that the metals react explosively with the steam. That is why the either sodium metal or calcium metal or potassium metal are not suitable for this for this experiment. Then instead to commercial uses of hydrogen. So state two commercial uses of hydrogen, and in this case we want to be very specific. There is a difference between commercial uses and industrial uses. So if you are supposed to give the industrial use, give the uses of hydrogen. How is it being used in the industry? Like that it is being mixed with hydrogen, it is mixed with oxygen, then to produce hydroxygen, hydrogen flame, which is used for welding and the cutting of metal. That is an industrial use. You can also say that it's used in hardening of animal oils to fats. But if it is the commercial uses here, that it is a commercial use, you can just say that it is used in filling balloons because it is lighter than air. And also there is a question which normally comes, why is hydrogen being preferred in filling balloons compared to helium? That is a question of that we can discuss later. What I want to emphasize is that from now be able to distinguish between the commercial uses of hydrogen and the industrial uses of hydrogen. So generally here we can state the uses of hydrogen. The general uses, it can be used in hydrogenation. Hydrogenation is the process of the hardening of animal oils to fats. There is also, it can be used as a starting material for the manufacture of ammonia in HAPA process, whereby it can be mixed with the nitrogen gas, then it produces ammonia, and it produces ammonia gas. As I also said that it is mixed with oxygen. Once it mixed with oxygen, it produces oxyhydrogen flame, which is used in welding and the cutting of metal. Another question, explain why helium is preferred to hydrogen in weather balloons. Why is the weather balloons are normally filled with the helium with helium instead of using this hydrogen? So unlike hydrogen, you just say that helium is inert, it does not react. So it is inactive, it does not react with the air. There is this one also, give two disadvantages of using hydrogen as a fuel. So you can also get from here that another use of hydrogen can be used as a fuel. What are the disadvantages of using this hydrogen as a fuel? So hydrogen as a fuel, in this case here, the two disadvantages: it is very expensive to obtain hydrogen, and number two, its reaction with oxygen is very explosive. So it reacts with oxygen explosively, and then it is very expensive to obtain hydrogen gas. Give one advantage of using hydrogen as a fuel. So the elements of water is just water is made up of two elements, that is hydrogen and oxygen. So in that case now, if you want the one advantages of using hydrogen as a fuel, you just say it reacts with oxygen to produce water. Water is used for domestic purposes. Which property of hydrogen makes it possible to be collected using the above method? As you can see here, the hydrogen is collected over water method. So what property makes this oxygen to be collected by what property makes this hydrogen to be collected by this one here? The property makes here it is insoluble in water. So those are some of the simple questions that you can expect from this particular diagram. Reaction of magnesium, reaction of magnesium with this thing. Don't forget to follow my channel, watch and share, subscribe. In our next class, we are going to discuss questions on the preparation or preparatory preparation of hydrogen.